One of today's leading and most respected physicists recently shared his thoughts on a breakthrough discovery. Michio Kaku, well known for his extraordinary contributions to physics as a whole, has confirmed that the James Webb Space Telescope made a remarkable discovery: 6 enormous galaxies that were previously considered impossible. The potential for this discovery to significantly improve our comprehension of the universe makes it an exciting development to monitor closely. Kaku, a renowned figure in the scientific community, is of both American and Japanese descent. He is an expert in physics, from classical experiments to quantum mechanics. Unlike more cautious scientists who are skeptical, Kaku is open to the remarkable results of the James Webb Space Telescope. His willingness to adopt these findings results in a refreshing perspective to the discussion, and we are delighted that such an eminent scientist has decided to speak out, sharing what is now undeniable. The enthusiasm, and even amusement, in Kaku's tone is evident as he talks about the James Webb Space Telescope's discoveries. He sees it as a recent event that has sparked his passion for the subject. As we examine the repercussions of Kaku's view on the significance of the 6 colossal galaxies discovered by the telescope, we begin to see the larger picture. Michio Kaku's first impressions. Kaku has always been a scientist willing to investigate new theories and ideas. He understands that Einstein's laws, Newton's principles, and the theory of relativity alone cannot fully explain the complexities of the universe. Kaku believes that the new findings from the James Webb Telescope have the capacity to significantly enhance our scientific comprehension. Despite the fact that many of his peers remain reluctant to accept this perspective, their hesitation has prompted concerns and debates among both supporters and critics of the Big Bang theory, as well as among those for or against quantum mechanics. Notwithstanding these reactions, Kaku remains unfazed, often finding humor in the skepticism. The discovery of the 6 galaxies. The James Webb Space Telescope's revelation of 6 enormous galaxies, dating back to the earliest moments of the universe, has stunned astronomers. These galaxies contain significantly more stars than the Milky Way, despite having formed only 700 million years after the Big Bang. The group of astronomers responsible for this groundbreaking discovery coined the term universe breakers for these extraordinary galaxies, as their existence could significantly change our entire understanding of the cosmos. These new discoveries challenge the established understanding of the Big Bang. According to current theory, immediately after the universe's initial explosion, it was in a state of chaos and extreme heat. The first substantial structures took hundreds of thousands of years to form. It was assumed that galaxies, especially highly organized ones, emerged much later. However, some of these brand new galaxies are more massive than the Milky Way. Their enormous luminosity suggests they were rapidly forming stars, perhaps hundreds annually. By contrast, our galaxy forms stars more gradually. The precise moment when the first galaxies emerged remains unclear. It is widely believed that isolated stars or small groups of stars existed first, gradually combining into larger accretions and eventually evolving into dwarf galaxies. These smaller galaxies would have then collided with others, growing into the massive structures we observe today. Rethinking the timeline. Based on previous models, such large and complex galaxies could not have existed so early in the universe's history. This raises the intriguing possibility that the universe may be significantly older than previously thought, or that elaborate galactic structures developed much earlier than anticipated. However, this theory remains difficult for more traditional scientists to accept. Some factions of physics strongly reject this discovery, questioning the accuracy of age estimates. Kaku, aware of these challenges, remarked that many outdated and inaccurate theories continue to persist due to the prestige of certain scientists. These outdated models were only discredited once key experiments revealed their flaws. Therefore, the foundation of science, particularly in physics, is held by experimentalists who hold theorists accountable. Understanding the cosmos. When it comes to understanding the true beginnings of the cosmos, humanity knows extremely little. The Big Bang theory and our comprehension of it have evolved over time. In 1927, the theory was proposed based on observations of the universe's expansion. According to these observations, the universe began with a single point and has been expanding ever since. At the time, the concept of a universe with a beginning and an end was nearly impossible for many to grasp. Even today, scientists continue to struggle to fully comprehend the actual nature of the universe. But the latest discoveries, while seemingly contradicting the Big Bang theory, should be considered with an open mind. Science has repeatedly demonstrated that progress often comes from revisiting old ideas. The confirmation of brand new hypotheses and discoveries is an essential part of the scientific process. A historical perspective. For example, When Einstein was a child, people believed that planets and stars were stationary, occupying fixed places in the cosmos. Now we know that everything in the universe is in motion. Planets and stars orbit within galaxies at incredible speeds, and entire galaxies soar through space at astonishing velocities. Their final fate remains uncertain. Today's scientists must accept uncomfortable truths, realizing that theories are not absolute and must undergo rigorous testing before being considered valid. Rethinking redshift. The Big Bang Theory's perspective on the universe emerged from the observation that galaxies are distancing themselves from one another, with the speed of separation proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding for a considerable amount of time. Supporting evidence, such as cosmic background radiation and the redshift of light from distant galaxies, helped reinforce this idea. However, it's crucial to remember that past societies also held erroneous beliefs, such as thinking the sun revolved around the Earth or that the Earth was flat. These beliefs were supported by the evidence available at the time, until technological advancements revealed clearer truths. We may now find ourselves in a similar position with the James Webb Space Telescope. Its findings have not confirmed the Big Bang as expected. Instead, the discovery of 6 massive galaxies challenges prior assumptions. The role of redshift. Redshift is a tool used by researchers in cosmology to measure the movement and distance of celestial bodies. It refers to the change in the wavelength of light as the light source moves relative to the observer. For instance, when a vehicle approaches, its engine sounds louder. As it moves away, the sound fades. This principle applies to light as well. When a light source moves toward the observer, it shifts toward blue. When it moves away, it shifts toward red. This phenomenon, redshift, is used to calculate the velocities and distances of celestial objects. However, even small errors in these measurements can significantly impact results. Implications for physics and cosmology. The implications of these discoveries stretch far beyond astronomy. They strike at the very core of physics and cosmology. If these galaxies did form so early in the universe's history, it suggests that our understanding of the universe's expansion rate, the formation of structure, and even the laws governing matter and energy in the early universe may need to be revisited. Some physicists suggest this could point to a flaw in our models of dark matter or dark energy, which are crucial components in our current cosmological theories. Others speculate that alternative models, such as modified gravity or variable speed of light theories, may better account for these early galactic structures. Kaku, ever the forward thinker, stresses the need for the scientific community to approach these discoveries with humility and openness. He believes that clinging to outdated models simply because they are widely accepted undermines the spirit of scientific progress. In his view, theories must evolve with evidence, not the other way around. The scientific method in action. This situation serves as a perfect example of the scientific method in motion. It begins with observation, in this case, the James Webb Space Telescope's stunning images of ancient galaxies. Then comes hypothesis and debate. Scientists across the globe are now working to explain how these galaxies could exist at such an early point in time. Next will come rigorous testing. Researchers will review redshift data, analyze light spectra, run simulations, and compare observational data to predictions from various cosmological models. Over time, these efforts will help refine, or completely reshape, our understanding of the universe. This process is not about immediately replacing the Big Bang Theory, but about refining it or exploring whether alternative models better fit the data. Science, after all, is not static. It thrives on change, challenge, and constant curiosity. A new era in space exploration. The James Webb Space Telescope has only begun to scratch the surface of what it can show us. Its ability to see deeper into space, and further back in time, than any telescope before it makes it one of the most powerful scientific instruments ever created. As it continues to observe the most ancient light in the cosmos, more surprises are sure to follow. We may discover more universe-breaker galaxies, evidence of even earlier star formation, or structures that defy every current theory we hold. These discoveries not only reshape how we understand the universe, they also redefine humanity's place within it. Each new piece of evidence is a reminder that the universe is vast, mysterious, and still holds countless secrets waiting to be uncovered. Conclusion: the cosmos reconsidered. We are living through a scientific revolution. The discoveries made by the James Webb Space Telescope may prove to be a turning point in modern cosmology. Whether they result in a slight revision of current theories or a complete overhaul remains to be seen. What is certain, however, is that the spirit of discovery is alive and well. Scientists like Michio Kaku, who are willing to embrace new ideas and explore unconventional possibilities, are essential to moving science forward. In the end, the universe is not obligated to fit our models. Our models must fit the universe. And with each new revelation, we step closer to understanding the grand design of the cosmos, and our place within it. This is perplexing. After the Big Bang, the revelation raises a potential paradox. How could such massive and highly organizational galaxies emerge so rapidly in a universe described by the Big Bang theory? It ought to have been in a significantly less stable and ordered state. While many researchers are still cautious, others are embracing this discovery as an opportunity to re-evaluate long-held beliefs. Michio Kaku himself has emphasized that science is an advancing field in which new discoveries challenge and even reverse existing theories. He noted that there are many instances where concepts once considered irrefutable were eventually proven wrong. For instance, the theory of a geocentric universe was widely accepted for hundreds of years, only to be overtaken by the heliocentric model. Similarly, the 6 galaxies discovered by the James Webb Space Telescope may eventually lead to a major shift in our comprehension of the universe's beginnings. In his remarks, Kaku emphasizes the significance of accepting new ideas and remaining open to revising old theories. The role of experimental physics, in particular, is critical in this process. It is the work of experimentalists that keeps theoretical science grounded in reality. New discoveries, like the detection of these galaxies, challenge existing models, causing scientists to rethink their assumptions and adjust their theories. Consequently, even though many may resist this paradigm shift, Kaku's optimism and openness to change serve to keep the dynamic nature of scientific advancement in mind. He encourages others in the field to maintain a sense of curiosity and wonder, understanding that scientific investigation is driven by a willingness to explore the unknown. Just as we once believed that stars and planets were fixed in place, we now comprehend that everything in the universe is in motion. The same principle applies to our comprehension. Theories of the cosmos must be adaptable, evolving as new data emerges. As we continue to explore the universe with advanced technologies like the James Webb Space Telescope, we must keep our understanding humble and remain aware of the limitations of our knowledge. The discovery of these 6 massive galaxies is just the beginning of a new cosmological chapter. It will likely inspire further research and testing, and we might one day look back to this moment as a crucial turning point in our understanding of the universe's history. The use of redshift as a tool for determining cosmic distances is one example of how scientists gather data to test their theories. By observing the way light shifts in response to the motion of celestial objects, astronomers can estimate how far away those objects are, and how fast they are moving. This technique has greatly aided our understanding of the expanding universe. However, as we've seen, it's not without its challenges. Small errors in measurements can have significant effects. As technology advances, new methods of measuring and analyzing cosmic data may emerge. Given the universe's complexity and the limitations of our current technology, it is essential to remain open-minded and willing to reassess long-standing theories. The discovery of these 6 galaxies has prompted more questions than answers, but it also offers an exciting opportunity to explore the cosmos in new ways. Scientists need to keep improving their methods, put their theories to the test, and remain open to the possibility that the universe may be even more mysterious and intricate than we currently believe. The future is abundantly clear. We are on the cusp of a new era in cosmology. The James Webb Space Telescope has already produced revolutionary results, and its ongoing discoveries will likely reshape our comprehension of the universe. The cosmos is new and full of surprises. As new information comes to light, our knowledge will continue to evolve. Just as past generations of scientists had to let go of outdated beliefs, today's researchers must be willing to accept new concepts and rethink the status quo. The discovery of these 6 massive galaxies serves as a reminder that science is a journey, not a destination. It requires curiosity, open-mindedness, and the courage to ask even the most basic questions about widely accepted theories. As we continue, we can only hope to venture further into space. The James Webb Space Telescope's discoveries may unlock even more cosmos-related mysteries and lead to deeper insights into the origins and evolution of the universe. As we stand on the precipice of these groundbreaking revelations, the potential for redefining our position in relation to the vastness of space is greater than ever before. The 6 massive galaxies discovered by Webb challenge preconceived notions. And while there is still some skepticism in certain quarters, the fact that they exist and are being examined more closely signals a crucial turning point in our understanding of the universe. Could we be witnessing the dawn of a brand new era of cosmology, where the boundaries of the past are pushed and new paradigms emerge? In the coming years, scientists will absolutely continue discussing, analyzing, and re-examining these discoveries. But one thing is certain, the study of the discoveries made by Webb is far from over. They provide a new perspective and encourage scientists to abandon outdated notions and embrace a future where anything is possible. As additional data are gathered, we will be able to see whether these galaxies offer clues to a deeper understanding of cosmic evolution, potentially altering everything we believe to be true about galaxy formation and the Big Bang. As Michio Kaku emphasized, scientific progress thrives on challenging existing knowledge. The discoveries from the James Webb Space Telescope encourage us to consider alternatives to the usual and to question everything in the world of physics. Cosmology and astronomy are ever evolving, and the forthcoming breakthroughs will play a crucial role in shaping the future of our understanding. For those of us following these developments, it's an exciting time to be part of the scientific community. We are just getting started on unraveling mysteries that were once considered unthinkable. The future appears extremely bright. As we continue to look deeper into the stars with the help of amazing technology, stay tuned as we keep exploring the universe's wonders, and, as always, keep questioning and staying curious. There are solutions waiting to be discovered. As humanity pushes the boundaries of observational capability, instruments like the James Webb Space Telescope are not just providing sharper images, they're challenging the very framework upon which modern cosmology has been built. Each new discovery isn't just a data point, it's a question mark cast over long-accepted theories, prompting a re-evaluation of what we thought we understood about the formation of stars, galaxies, and even time itself. Already, discussions are intensifying within scientific circles. Are these massive galaxies outliers, or are they indicators of a much faster and more complex galactic evolution than previously thought? If so, what forces or phenomena could have accelerated their growth in the early universe? Could there be previously undetected laws or conditions that govern the universe's infancy? These questions are not just theoretical, they carry the potential to reshape how we interpret the cosmic microwave background, the role of dark matter and dark energy, and even the fundamental structure of spacetime. Moreover, this paradigm shift isn't happening in isolation. Alongside the Webb telescope, next-generation observatories, both spaceborne and ground-based, are being designed to follow up on these questions. Missions such as the Nancy Grace Roman Space Telescope, the European Extremely Large Telescope, ELT, and others will provide complementary data, cross-verifying the Webb's findings or perhaps introducing even more surprising contradictions. The scientific method thrives in this atmosphere, where answers lead to more questions, and certainty gives way to curiosity. It's a reminder that our understanding of the universe is not static, but a living narrative, continually shaped by exploration, observation, and a willingness to challenge dogma. As we stand at this frontier, one truth becomes increasingly evident: the cosmos is far more intricate, dynamic, and mysterious than we have ever imagined. What lies ahead may not just redefine our models of galaxy formation, but our place in the universe itself. So stay curious, keep watching the stars, and remember, every photon captured by these powerful telescopes carries with it a whisper from the distant past, a message waiting to be interpreted, a secret waiting to be uncovered.